Everyone on TikTok is losing their minds over this James Webb image, claiming it's definitive proof of sprawling alien cities on distant exoplanets. Be honest, when you first saw those leaked images, did a part of you want them to be real? Drop a yes or no in the comments. I won't judge, because the CGI is getting scary good. But before you believe the hype, we need to talk about what those cities actually are, because the reality is far more scientific and, honestly, a lot less sensational. But to understand why these cities are a physical impossibility, we first have to look at a fundamental law of the universe that even NASA can't break. Let's start with the single pixel problem. The nearest exoplanet to us, Proxima b, is 4 light-years away. At that distance, the planet itself is a sub-pixel object. You can't resolve its shape, let alone the lights of a city on its surface. To actually resolve city-sized features on Proxima b, you would need a telescope mirror kilometers wide. The James Webb mirror is 6.5 meters. That's not even close. The resolution limit is a hard wall built by the laws of optics. You can't engineer your way around it without fundamentally changing the size of your instrument. Here's the analogy that makes this click. You're standing at one end of a football stadium. At the opposite end, someone places a penny on the turf. Then they aim every stadium floodlight directly at your face. The glare is blinding. Your eyes are watering. And through all that blazing light, your job is to read the tiny date stamped on that penny 100 yards away. That's the challenge of seeing city lights on an exoplanet. The star is millions of times brighter than any reflected light from the planet. The planet itself is the penny, lost in the glare. And you're asking a 6-meter mirror to somehow cut through all of it and resolve individual buildings. It's not happening. But here's the thing. Even if we built a telescope the size of a city to solve that problem, we'd immediately run into a second, much louder obstacle that most TikTok theorists completely ignore. You still have the noise problem. Space is loud. Scientists once found a bright cluster in one frame that looked exactly like a city grid. Turns out it was a single cosmic ray, one particle from a supernova thousands of light-years away, hitting the sensor at just the right angle. Stellar flares from the host star can mimic patterns that untrained eyes interpret as grids or domes. The sensor itself generates heat, which shows up as hot pixels in long exposures. All of this interference has to be filtered out before scientists can even begin analyzing the data. That's where the verification process comes in. Scientists don't just see a dot and claim a discovery. They use redundancy. If a signal appears in one exposure but not the next, it's interference. If it doesn't show up in multiple wavelengths, it's a glitch. Real discoveries survive this gauntlet because they're consistent across dozens of observations. Fake discoveries fall apart the moment you apply the scientific method. There's another layer to this. James Webb doesn't take pictures the way your phone does. It collects photons over hours and converts them into spectroscopy charts. Those charts show the chemical fingerprints of whatever light passed through the telescope. You're not looking at a photograph of a planet. You're looking at a graph that tells you what molecules are in its atmosphere. That's the data. There are no leaked images of glowing cities because the telescope doesn't produce that kind of image in the first place. Gravitational lensing adds another wrinkle. When a massive object like a galaxy cluster sits between the telescope and a distant target, it bends the light. This creates Einstein rings and arcs that look like curved structures to people scrolling TikTok. In reality, it's just a straight line of light being warped by gravity. The universe acts like a warped cosmic lens, and viral videos exploit that distortion to manufacture mystery where none exists. So, if James Webb can't see cities, what did it actually find that was so significant? Scientists spent months double-checking the data before they dared to whisper its name. Let's start with the confusion that sparked this whole mess. The telescope detected dimethyl sulfide on an exoplanet called K2-18b. That's a molecule only produced by life on Earth. Specifically, it's made by phytoplankton in our oceans. On our planet, these microscopic organisms pump out this sulfur compound as a byproduct of their metabolism. Finding that same chemical signature on a world 8 times Earth's mass, 120 light-years away, is genuinely extraordinary. It's a potential biosignature, a chemical flag that says something biological might be happening there. So we found a gas that on Earth only comes from life. On a scale of 1 to 10, how much do you actually believe this is a sign of alien life, and not just some weird geological process we don't understand yet? Let me know in the comments. But notice what that discovery is not. It's not a photograph of structures. It's not infrared hotspots arranged in grids. It's not electromagnetic signals broadcasting at regular intervals. It's a molecule, a single data point in a spectrum that required months of observation to confirm. Yet somewhere between the peer-reviewed paper and the TikTok algorithm, we found a gas made by plankton became NASA-photographed alien skyscrapers. The data says we detected a chemical that could indicate microbial life. That's the scientific claim. City lights were never part of it. Everything else is storytelling, designed to hijack your attention. What makes this discovery powerful is the method. James Webb is doing atmospheric sniffing, and it's revolutionary. The telescope waits for a planet to pass in front of its star, then captures the starlight that filters through the planet's atmosphere. Different molecules absorb different wavelengths of light. By measuring what's missing from the spectrum, scientists can figure out what gases are present. On WASP 39b, the telescope found water vapor, carbon dioxide, sulfur dioxide, and methane. This is the first time in human history we aren't just staring at a light in the sky. We're reading the chemical weather of a world we can never touch. Think about that. We're standing on Earth, pointing an instrument at a speck of light and reading the chemical composition of another world's atmosphere. That's not science fiction. That's what we're doing right now. The real breakthrough isn't a photograph of a city. It's a chemical fingerprint of a world we'll never visit. But there is one thing James Webb does that is actually more impressive than seeing a city. It's a capability that effectively turns the telescope into the closest thing humans have ever built to a functional time machine. The JD's survey is genuinely mind-bending. James Webb looked back to just 300 million years after the Big Bang. It captured light from the very first stars to ignite in our universe. Take Galaxy J ADES-GS-Z 13-0. The light we see from that galaxy today left its surface before Earth even existed, before the Sun formed, before our entire solar system was anything more than a cloud of dust. We're seeing galaxies that formed when the cosmos was still in its infancy, when the universe was a fraction of its current age. These aren't artist renderings, or simulations. These are actual photons that traveled for over 13 billion years through expanding space to reach the telescope. Every pixel in those images is a time machine. We're watching the universe grow up. That's the kind of discovery that forces us to rewrite cosmology textbooks and question our models of galaxy formation. But it doesn't make for good clickbait because it requires context and patience, and TikTok rewards neither. Compare that to the viral hoax. The fake videos use CGI from concept art or clips from science fiction movies. They add a grainy aesthetic to make it look like leaked footage. That triggers the "they're hiding something" response in viewers. The comments section becomes a feedback loop of conspiracy theories, and the algorithm rewards the conflict with more reach. Meanwhile, the actual data from James Webb is sitting in public archives as FITS files. Anyone can download them. There are no leaked images because nothing is hidden. The transparency is total, but transparency doesn't go viral. Here's why NASA seems slow to announce things. It takes 3 seconds to make a fake TikTok video. It takes 300 days of calculations to confirm a single gas on an exoplanet. Peer review is a gauntlet. Data goes from the telescope to a research team, then to a paper, then to anonymous experts who try to find every possible mistake. That's not a cover-up. That's quality control. And here's the part that matters. The algorithm rewards speed and conflict, not accuracy. A fake video claiming NASA is hiding alien cities gets pushed to millions of feeds because it triggers emotional engagement. A carefully vetted discovery about atmospheric chemistry gets buried because it requires patience. Real science doesn't move at the speed of social media because the scientific method and the engagement economy have opposite incentives. The genuine discoveries are more exciting than the fake ones. Finding the chemical ingredients for life on a distant world changes the probability that we're alone in the universe. Watching stars being born in the pillars of creation gives us a window into our own origins. These are the milestones that matter, but they require you to slow down and understand the data. Viral myths only require you to feel something and hit share. You now have a 3-part toolkit for spotting fake space content. First, if it shows clear, detailed images of a planet's surface, it's fake. The physics doesn't allow it. Second, if the caption claims NASA is hiding something, it's engagement bait designed to trigger your distrust. And third, here's your secret weapon. If the stars in the background are twinkling, you're looking at CGI. Stars don't twinkle in space. That's an atmospheric effect that only happens when light passes through Earth's air. Remember at the start when I asked if part of you wanted those leaked cities to be real? Now you're equipped to spot the fake the second it hits your feed. You won't get fooled again. Real discoveries come with datasets, not drama. They come with months of verification, not 3-second clips. If you value accuracy over hype, subscribe and join the community that refuses to let misinformation win. Drop a comment and tell me which space myth we should dismantle next. Now that you know how to spot a fake exoplanet, you need to see what happens when the truth is actually weirder than the fiction. Click here to see the most terrifying real planets we've ever found.